extrude angle theorem and triangle inequality theorem. Let me Alright, so that's our title. And just like yesterday, using Sketchpad, I want to make it a little visual. And then we formalize everything later. So let me show you guys an angle on the outside. Let me scroll this down. You guys notice I have my triangle ABC, but I extended one of my sides, right? I extended to D. So I have an angle on the outside, right? You guys see it. My angle ACD is outside. And you guys see my angle ABC and my angle BAC, right? You guys see those measurements? In fact, let me scroll this a little bit more. Once again, for you guys to see that the numbers are not set, I move my point A, and obviously all the numbers change. If I move my point D, changes everything as well, so obviously everything changes. What relationship do you guys see? If I was to look at my two angles that I highlighted, my angle A, my angle B, obviously they're both smaller than the other one. By far we can see they're smaller. If I was to put those two angles, what relationship do you guys see between those two and now? They're what? They're equal to 180. Let's see. This is about a little more than 118. If I was to add it to 60, let's just run my numbers up. 119, 62, and 57. That will be more than 180, so not quite. They what was it? They add up to 118. Let's find out. We're going to calculate, we're going to say this angle plus the other angle. So it calculates the number there. We see equals to 118.83. Let me move this around. So if I add these two smaller angles, equals that other angle, right? Yeah. From what we can see. All right, let's formalize this. We're going to say the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So the measure of an exterior angle, so one exterior angle, is equal to the sum of the measures of the two non-adjacent interior angles. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. I know yesterday we talked about adjacent. So non-adjacent obviously means not adjacent. So what does non-adjacent mean? What was it? Congruent is equal. So, but adjacent, I talked about something about, I used the word adjacent yesterday. What does non-adjacent mean? Remember, it's not about equal, but congruent is equal. So adjacent is not that. So matter of fact, I'll say you two are adjacent next to each other. So adjacent means next to each other. So non-adjacent will be not next to each other. All right, so for us to be a little bit more visual, what I mean with this, so like you guys see this interior angle, 58.59, 52.73. You guys see those? The sum of those will be to the exterior angle that is non-adjacent. So in that case, it will be 111.32. Right, if we add it up, we can see it's true. You guys notice I brought out all the exterior angles of a triangle and all the interior angles. Because it says any two. So if I was to find 127.27, right, if I was to find this angle, I will add this other two, the two non-adjacent angles. Does that make sense? All right, let's look at another formula. But for this, let's do this. Those measurements, 4 centimeters, 3 centimeters, those measurements are the measurements of the lengths. So I have three cases. I notice that the two sides, the two smaller numbers, 3 and 4, are less than 8. I want to see if I can create a triangle with those. All right, I can move my sides. I want to see if I can create a triangle. All right, no matter how much I close it, is that a triangle? Right, they never touch. All right, so that's not going to work. Now, let's say the two smaller sides are equal to the bigger side. Right, 3 and 5 are equal to 8. Let's see if that works. I'm going to bring this thing down. Right where they will close will be right there. Is that a triangle? Now that's a line segment. So it doesn't work. So if the two numbers are less than the bigger number, it doesn't work. If the two numbers are equal to the bigger number, it doesn't work either. Let's take a look at what if the two numbers are more than the third side. Right, if I close these, is that a triangle? Yeah, so what can we say about these?
Anything less
So that's good. It's good you guys are thinking. Remember, we're gonna formalize it a little, so it's okay. We throw in. Remember, I said there's three languages: the student language, book language, and teacher language. So let's talk about it. Student language. What can we say about this? Right. So everything that is equal to. So you're looking at the middle case. Everything that is equal to or less than. Is that a triangle? So to formalize it, can we just come and say the sum of the two small lengths of any triangle must be greater than the third side? That formalizes it? Alright, so let's write this thing down. Triangle inequality theorem. The sum of the two smaller lengths of any triangle must be greater than the third side. Keep in mind I said that the two smaller sides. The sum of the two smaller lengths must be greater than the third side. The way you guys will see this in your homework, let's say I was to give you guys two measurements, 4, 3, and 6. They're not in any order, they're just three numbers. And I can see that two smaller numbers are 4 and 3. Right, my question to you guys would be, will these three numbers make a triangle? So I'm looking for yes or no. Yes. Right, because if we add the two smaller numbers, it's bigger than the third side. But what if I have something like, let's say 3, 3, and 6?
No.
Because 3 plus 3 is not more than 6. All right, so that's how we're going to see it on the worksheet. Let's take a look at the last rule we're going to see today. Once again, the numbers, 5 centimeters is the length of the measurement, 8 centimeters the length of that measurement, and x, I have it as x because as you guys can see, I can change the triangle. So I'm calling it x because that varies. 5 and 8, if I move it around, 5 and 8 don't change. The only one that changes is x. But the cool thing is that I have it calculated over here. That's the value of x. So once again, if it changes, it changes. If I move the point, it changes the value. So let's see, what's the smallest value that it can be? It's 3, and it starts getting bigger because I'm on the other side. So it can be as low as 3. Let's see what's the biggest number it goes to. So I'm getting bigger and bigger. Get to 13, and I get to the other side. So using those two numbers, 5 and 8, Remember, the smallest value was 3, the biggest was 13. How can I, from 5 and using those two? Yes.
But you said if you go to the biggest number and add even more, so 3 wouldn't count, would it?
3 wouldn't count. Okay, good. So it cannot be 3. It has to be strictly greater than 3, right?
So 4 higher.
So, well, 3 point something. So higher than 3 and less than 13, right? But the 3, how can I come out with the 3 having the initial measurements, 5 and 8? How can I come out with the 3 from those? Subtract. How can I come out with the 13? Add. All right. So let's formalize this. Knowing the length of two sides of a triangle, the third side must be greater than the difference of the two known sides, but less than the sum of the two sides. Oh, you guys are copying that. Let me pass out the worksheet. Alright, knowing the length of two sides of a triangle, so knowing the length of two sides, the third side must be greater than the difference of the two known sides, but less than the sum of the two sides. And just like you guys mentioned, it cannot be equal to, so there's no less than or equal to, I said strictly less than. When it says greater than, it says greater than. There's no or equal to, right? Can I take that out? Let's just this, keep the pencils moving, so let me hold on a second. So just looking at the object that we had earlier, the way we will write this, for the values of x, I'm going to say, see how x is greater than 3, but less than 13. I'm saying the values between 3 and 13, but remember, we cannot include those, so that's why I don't have or equal to. So if I ask you guys, give me the range for the third side, this something like this is what I'm expecting. Like if this was a question, I will say 3 is less than x, but x is less than 13, right? Basically what we have. So that's what I expect. Once again, can I take this off?
So, Mr. Leonzo, you were saying how it could be, like, say, if you're trying to get 5 and 8, it could be 3 point something?
It could be 3 point something. If I move this, look, like 3.48 gives me a triangle. Like 3 point something. So in other words, it's strictly less than, greater than 3. Decimals are included. Alright, so let's take a look at our worksheet. Solve for x. I notice there's an exterior angle and there's two interior angles. And then we talked about earlier that the exterior angle is equal to the sum of the two interior angles. So the way I'm going to solve for x, I'm going to go 3x plus 4 plus 3x minus 6. Right? I'm adding the two interior angles. And this is equal to 7. Add the two interior angles and equals the exterior angle. Alright, let's separate through the equal sign. Let me simplify the left. How much is 3x plus 3x? 6x. How much is 4 minus 6? Negative 2. So we have 6x minus 2 equals 70. Right? We just simplified it. Then minus 2, let me move it to the other side as a plus 2. 6x is equal to, how much is 70 plus 2? 72. So 6 times x equals 72. What's x? 12. X is equal to 12. Right, that's it. Alright, add the two interior angles and equal the exterior angles. Right, so add the two interior angles and it equals the one exterior angle. That's all we do. Right? I know on the notes I gave it to you guys, there's numbers. We can change it to letters. So this takes care of what? The first 8 questions? Any questions on the first 8? Which one? Number 2. Alright. Let's take a look at number 2. I'm going to add the two interior angles. So I'm going to go 7x plus 11 plus 67 is equal to 13x plus 18. I'm going to separate them to the equal side. I'm going to simplify the left. So 7x is just 7x. How much is 11 plus 67? 78. So we have the 7x plus 78 is equal to 13x plus 18. Alright, letters on one side. So my 13x from the right, let me move it to the left as a negative 13x. Right, switch sides. My 78 from the left, let me move it as a negative 78 on the right. Letters on one side, numbers on the other. On the left, how much is 7x minus 13x? Negative 6x, yes? On the right, how much is 18 minus 78? Negative 60. There's negatives, we can deal with it. X equals 10. Not bad, right? Letters one side, numbers on the other. Alright, any other questions for the first 8? Moving along still, question number 9, very similar. It says question number 9, I'm asking you guys, find the measure of the angle indicated. Here I'm asking you guys, how big is angle B? Angle B, we notice, is 17x minus 2. So solve for x, and then plug it in. The way we're going to solve for x, I'm going to add the two interior angles. I'm going to go 17x minus 2 plus 28x is equal to 88. Let me simplify the left. How much is 17x plus 28x? 45x, okay. 45x minus 2 is equal to 88. Right, we just simplified the left. That's all we did. My minus 2 on the left, let me move it to the right as a plus 2. Right, we switch the side. So we get the 45x. How much is 88 plus 2? 90. If 45x equals 90, what's x? 2. Alright, now that we know the value of x, plug it in an angle V. 17x minus 2. So go 17 times x minus 2. How much is that? What is it? 32. Alright, so our answer is 32 degrees. Once again, here I'm asking you guys to solve for x and then plug it in. Alright, so this takes us at what tonight? Number 16? Number 10? Alright. Let's take a look at number 10. Let me add the two interior angles. So I'm going to say 9x minus 8 plus 56 is equal to 16x minus 8. Right, add the two interior angles and equals the exterior angle. Let me simplify the left. 9x is just 9x. How much is negative 8 plus 56? 48. On the right, I have 16x minus 8. Alright, let me have letters on the left side. So 16x from the right becomes negative 16x on the left. 48 on the left becomes negative 48 on the right. How much Negative 7. Alright guys, let's keep on paying attention. How much is negative 8 minus 48? Negative 56. If negative 7x equals negative 56, what's x? 8. Alright, let's grow up a little. Alright, and then let's use x. Let me plug it in. It's asking me to find the angle TBC. If I connect TBC, it's talking about this angle. So x equals 8. Plug it into there. 16 times x minus 8. Not quite. 120. Way up. Alright, so, because we went 16 times 8, which is 128, minus 8, 120. Alright, any questions for the first 16? Alright, let's take a look at 17. Stated that three numbers can be measures of the sides of a triangle. Once again, the numbers are not in any order, but I do highlight my two smaller numbers. Like I said, they're not in any order. They're just listed. I highlight my two smaller numbers. Can those be the measures of a triangle? Yes. And we know yes because 8 plus 8 is more than 11. Okay. So any questions up until 24? Alright, now looking at 25. Two sides of a triangle have the following measures. Find the range of possible measures for the third side. So my two numbers are 11 and 7. What's the smallest number that it could be?
7.
Not quite 7. Remember, for my range, I'm going to put my x in between two numbers. What's my small number, my small value? 4. So we subtracted the two numbers, right? 11 minus 7 is 4. What's my big value here? 18. So remember, we added the two values. For the small value, we subtracted 11 and 7. For the big value, we added 11 and 7. So x is in between 4 and 18. Right? Any number between 4 and 18 will do it. Okay. So if it says find the range, that's what I'm looking for. Right? Any question?
So that's where you're going to put it.
This is it. Yeah, this is it. The range is basically I'm saying x is between 4 and 18. Any value will do it. Yeah. 19? Alright, let's take a look at number 19. I'm given three values. The two smaller values are 8 and 1. Right? The biggest one is 8. Can this be measures of a triangle?
Yes.
Because we add the two smallers and it's greater than the third one. So yes. Any other questions?